Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over solubility equilibria and the solubility product constant. So let's get into this. So in previous videos I've talked about solubility and how to determine whether something is soluble or not. Your teacher or professor has probably gone over solubility and has shown how to use a solubility table or how to use your solubility rules to figure out if something is soluble or not soluble. And it's either one or the other. So in this video and in my other future videos that I'm going to be putting out, I'll be talking about how you can determine the degree of solubility. So some things are more soluble than others, even though they are soluble. So we can determine that by finding what is called the solubility product constant and using that to indicate how soluble something is. So, what is a solubility product constant? Well, what we can do is we can kind of treat solubility or the dissolving of a solid as an equilibrium process. So, here I have an example. So, here I have calcium fluoride, and it's a solid and it's going to dissolve in water. So, I have some calcium ions and some fluoride ions on the product side. So here I'm representing an equilibrium where some of the solid is dissolving such that the ions are coming apart, and so they're being hydrated and separated by each other by the water molecules. And so we have them as aqueous here and here, but these ions can come back and reform the solid and become deposited on the solid here. So we could represent this as an equilibrium process. And so, like all equilibrium processes, they have a constant, an equilibrium constant that goes with them. We've seen this with, for example, your Ka values for the ionization constant for an acid, or your Kb value for the ionization constant for a base. Or we saw that with your Keq, or your equilibrium constant for any reaction, right? A reaction that's reversible. So we've seen a lot of these before. So now we're going to see what is called the KSP, the solubility product constant. And so just like all of these, their general equation is going to be the K is equal to the concentration of your, here, I'll just do this in terms of reactants and products. So it's the concentration of whatever your reactants are. So we'll do the, I'm sorry, your products. And they're raised to some power, which is the power of the coefficient. So we could say A is your coefficient. And that's going to be divided by the concentration of your reactants. And they're raised to some coefficient. So whatever the coefficients are. So this is a very general idea. Usually it looks something like this. So you have your KEQ, and if you have a couple of products, then you'd have product, let's call them C and D. So concentration of C raised to the coefficient C for that product, and then D raised to the coefficient of the raised to the power of the coefficient for that product. And if you have a couple of reactants, then it would be the multiplication of those reactants. So let's call that A and B. And so those are raised to their coefficients. So the general equation would be a plus little b, capital B, is in equilibrium with C. Oops, I should move this over, give some space. So we have little a plus little b in equilibrium with little c plus little d. And so there's the general equation. And so when we're trying to find the equilibrium constant for this, it's assuming these are aqueous, then it's going to be the products, the concentration of the products raised to their coefficients, raised to the power of their coefficients, so C and D, so C and D, and then over or divided by the concentration of the reactants raised to their coefficients, the power of their coefficients A and B. So this is the general equation. And so you would do the exact same thing with the solubility, with the dissolving, the equation where you're dissolving a salt in water. So if there's an equilibrium there, then we can apply this to this. And so we remember that anytime you have a solid or a liquid in your equation, you ignore those. So those do not go into the equilibrium expression. And so for KSP, for this example, and any other example you have of a solid or a salt dissolving in water, it's going to be KSP for this one. Since this is a reactant and reactants are on the bottom, and this is a solid, we're going to not include that in our expression. So it's just going to be the concentration of the products here, of the ions. So it's going to be the concentration of Ca2 plus raised to the power of its coefficient, which is 1, multiplied by the concentration of this ion, which is the fluoride ion, raised to the power of its coefficient, which is 2. So then this is the expression for the solubility product constant. And so this solubility product constant will tell us how soluble the salt is in water compared to other salts. So then we can use this to identify or gauge how soluble something will be compared to other things. I hope this is helpful. I hope you enjoyed this video. If you learned something from this video, if this cleared things up for you, then please like the video right there in that, hit that like button right there. Also, make sure you subscribe to my channel and hit that notification bell right up there somewhere. And so that way you can be notified by other videos I put out. Also, please put a comment down in the comment section below. Let me know what you think. If you have any questions, please ask. I love to answer questions. Thank you for joining me. Have a great day.